Hello. In this video we're going to take a look at section 6.2, which is graphing linear equations. Some of the content here is actually relevant to the section 6.1 Hawks assignment, so if you notice that you're struggling with that assignment, this video might be helpful for you. I'm assuming that you've already become familiar with the material in section 6.1, and if not, please make sure that you check out the video that I recorded on that and read through the textbook. So I am assuming that you are basically familiar with the concepts of plotting points in the coordinate plane and identifying points in the coordinate plane. So we're going to start with some concrete examples that are not necessarily exactly like the ones that you'll see in Hawks, but maybe will hopefully help reinforce the basic concepts of what's going on here, because it's important to understand the basic ideas of what's going on here and to be able to understand why we're actually learning this stuff. So here's an example of something that pertains to all of you guys, and that's this graph represents the rates of college tuition as time has gone by for the average tuition for all public institutions in this country. And the nice thing about this graph is it very visually and very clearly represents what's going on here. It depicts the fact that tuition's been going up, right? And you can see that very clearly. You can even see that the rate of change has increased. It's going up faster than it used to. And that's something that you can't get by just looking at raw numbers. This really drives home what's going on. Now I know this is glossing over some things like the fact that there's inflation and that the cost of living has changed as well. But this still really clearly depicts what's going on in a way that just looking at the numbers won't. And that's why this concept of using a graph to represent a relationship between two things is so important. Something that we're going to learn about next week, which is also super cool, is how you can take data like this and construct a model, construct an equation that you can use to make predictions, which is really also pretty neat. So the important ideas here are that this graph has an independent variable, an x value. Those are the ones going along the bottom, or the academic years. And then the vertical values here, the ones going up and down, are the dependent variables, the y values, and that's the average tuition. So every graph is going to have an independent or an x variable and a dependent or a y variable. And the dependent variable depends on the x variable. That's why it's called dependent. The tuition depends on what year it is. It's gone up over time, and we think of the independent variable as the input and the dependent variable as the output. So I could give you a year, and you could use this graph to look up the tuition that year. The tuition depends on the year I give you. And similarly, when you see the general equations with the y's and the x's, the y is going to depend on an input that you give for x. Alright, let's take a look at a real example here, and this is one that's very similar to an example in Hawks, but still gives you a bit of a concrete setting. And we're going to, again, try to create a graph that represents a relationship between two variables, because that's what that line's supposed to do. And in this example, a taxi cab charges a fare of $2 per mile plus a $1 base fare. So they're charging you $1 just to get in the cab, and then every mile they're charging you another $2. So you've got two variables here. You've got the distance that you go and the amount that they charge you. The number of miles is independent, that's your input, and the cost of the cab ride is dependent. So you don't get in the cab and tell the cab driver that you want to spend $15 on a cab ride and ask him how far you can go and where to go. No, you get in, you tell him your destination, and then depending on the number of miles, he'll give you a cost. So the cost depends on the number of miles. And in fact, the relationship here is that the cost is equal to 2 times whatever number of miles, because it's $2 per mile, plus the $1 base fare. So as we said before, your independent variable is always going to be your x, and your dependent variable is always going to be your y. So we'll say that the miles is x, and the cost is y. And now our equation becomes this, y equals 2x plus 1. And this is the form that you're going to see most of the equations in. This is what you're going to be given, and you're going to be asked to create a graph for this. It's a really straightforward 3-step process. So let's take a look at that process. So they're going to ask you to graph the equation y equals 2x plus 1. Our first step is to select some inputs for x. Now in the section 6.1 Hawks assignment, they do this for you for most of the problems. But here, let's just come up with some possible cab rides. Let's be simple. Let's say we'll go for 1 mile, 2 miles, and 3 miles. Those are going to be our different cab rides. Next, we're going to create an input-output table. If I know that the cost of a 1 mile cab ride is $3, I can plot that as a point. I've got an x and I've got a y. So I can go back to the things that I learned from section 6.1 and plot that as a point. And if I do that with a bunch of points, I'll end up with a graph. So I need to come up with the y values for each x value. Here's how I like to format my tables. And they do this very similarly in the book. I'll have the x values that usually you get to choose, especially in the Hawks section 6.2 assignment, you'll get to choose these. Oftentimes they'll only ask you to choose 2 of them. I'm going to do 3 just for consistency. So I've chosen 1, 2, and 3 for my x values. And now for each of these, I'm going to substitute the red x in the equation here. When I see that x, I'm going to replace it with the value that I chose. So I'm going to rewrite the equation, y equals exactly as it is, 2. And now since the next thing I would write is the x, instead of the x, I'm going to write the number that I chose for x. But I'm going to put it in parentheses so that I remember it's a multiplication. Don't want to write down the number 21. I want to write 2 times 1, in other words. And then I'm going to bring down the plus 1. And I can just compute going across. 2 times 1 is 2, plus 1 is 3. And that makes sense, right? If it's $2 per mile and I'm going 1 mile, he's going to charge me $2 plus the $1 base fare, or $3, right? Let's see if we can do the next one. Y equals, and I'm going to bring down the 2. And now think to yourself, what should I write next? I don't want to write the x. I'm going to substitute in the value that I chose for x, which is 2, for this particular row at least. And I'm putting it in parentheses so that I remember it's a multiplication, and then plus 1. Now see if you can work that one out. 2 times 2 is 4, plus 1 is 5. Alright, last one. Go ahead and pause the video and see if you can work out what that last row ought to be. Did you get it? In this case, I'm going to have y equals 2 times 3 plus 1. So a 3-mile cab ride is going to charge me $2 per mile. That's $6 plus the 1 will give me $7. Great. What's the point of that? Well, each row has an x and a y value, an input and an output. These are things that we saw as ordered pairs in the previous section. So that first row with 1 for x and 3 for y would look like 1, 3 as a coordinate point, and you could actually just graph that point. And that's what we're going to do. We're going to plot each row as a point. And I've got a nice convenient grid here that I can graph in. So I'm going to plot that 1, 3. This is stuff from section 6.1. So again, if you're not sure how to plot points, go back and review that section. 1, 3 would be 1 in the x direction and 3 in the y direction, so right there. The next row is 2 for x and 5 for y. So I'm going to go over 2 and up 5. And then the last one is 3 for x and 7 for y. So I'm going to go over 3 and up 7. And as you can see, those 3 dots line up nicely. They make a nice straight line here. And that's the line that goes with this equation. The neat thing about this is you can actually use this line to make predictions. So if I wanted to know how much a $4 cab ride would cost, I would just look up above the 4 miles, and I see that the point should be right around here. If I look over to the y, it looks like it's about 9. And indeed, when you try to put in 4 miles, $2 per mile times 4 miles would be $8 plus the 1 gives you 9. So it actually works out. Pretty neat, huh? Alright, let's do a more abstract example with just x's and y's. Let's graph y equals negative 3x plus 5. You do have to be a little bit careful with the negatives here. So we can pick any inputs you want. I'm going to go with some simple ones here, just because I think it's nice to keep things simple. I'm going to go with 1, 2, and 3. And I'm just going to substitute those in for x. What I'd like you to do here is pause the video and see if you can get the y values associated with each of these, and then come back and see if you got them right. Alright, let's see what we got. First one, I've got negative 3 times 1 plus 5. Got to be careful with your negatives. Negative 3 times 1 is negative 3. And if I do negative 3 plus 5, the signs are different, so I end up subtracting these things, and I end up with a positive 2. Next up would be negative 3 times 2 plus 5. Negative 3 times 2 is negative 6, and negative 6 plus 5 is negative 1. And then last, I have negative 3 times 3 plus 5. Well, negative 3 times 3 is negative 9, And when I do negative 9 plus 5, I get negative 4. So let's graph this. My first point is 1, 2. That's easy, over 1 and up 2. My next point is 2, negative 1, which means I go over 2, but now I'm going down 1, so it's right here. And my last point is 3, negative 4. So I go over 3, and I go down 4. And one reason that I like to do 3 points is if you do it right, they should line up, so that gives you a good feel for it. Now, like I said, in the Hawks assignment, they'll often just have you do 2 points instead of 3, and they won't make the table for you. They'll give you a set of ordered pairs that looks something like this. And you've got to fill in the blanks. So in that set of ordered pairs, and they'd have a second one down here, in that set of ordered pairs, I'd write 1, 2, and then 2, negative 1. Or you could pick the 3, negative 4, either way. Alright, hopefully this helps you with some of those graphing questions from section 6.2. Just to review, the concept of graphing an equation of a line means you're taking the relationship given between the variables from that equation and you're making a line on the coordinate plane to depict that. To do that, you pick some values for x, substitute them into the equation, and get some y values. I like to keep that organized using a table. Each row gets plotted as a point in the xy coordinate plane, and then connect your points with a line.